Hey everyone, and welcome back. Before we begin here today, please make sure that you like and subscribe because it really does help us out over here. And it also really helps us reach others in need of assistance with these topics. So what we're going to be covering in today's video is trigonometry, and we are going to be calculating angles for right triangles using inverse trig functions. So we have three triangles here that we have to find the angle for. And for each of these triangles, we are just going to use one of our typical inverse trig functions. And that will be sine of our angle, cosine of our angle, and tangent of our angle. And we're just going to use the best one of these three for each of these triangles. We're not going to use every single one for each triangle. We're just going to look and see which one will be the fastest to use. So remember with sine, it's going to be of the SOH-CAH-TOA. So you have your sine is equal to your opposite over your hypotenuse. Cosine will be the COA portion, and that will be your cosine is equal to your adjacent over your hypotenuse. And then your tangent will be equal to the TOA, which is the opposite over the adjacent. So looking at these three triangles, let's see what sides we know and what would be the quickest trig function in order to solve for each of these angles. So looking at this first triangle here on the left, we have angle theta here. And this would be my adjacent side. This is my opposite side, and this is my hypotenuse side. Remember, your adjacent and your opposite always have to be meeting at the right angle. And your hypotenuse is the longest of the sides that is opposite that right angle. So looking at what I have here, I have my opposite side and I have my hypotenuse side for this angle. So whenever you have the opposite and hypotenuse, that would be your sine. So the sine of theta is equal to my opposite over my hypotenuse. So the sine of theta is equal to square root of 3 over 2 square roots of 3. So my sine of theta would just be, well, this comes out to be just a half. So theta would be the sine inverse of 0.5, which gives me 30 degrees for my angle right here. So there's one of my triangles done. Now let's move on to the other one. So my angle is right here now. So this side right here touching the angle would be my adjacent side. The other side that is connected into the 90 degrees that is not touching my angle would be my opposite. And of course, my hypotenuse would be my longest side opposite my right angle. So looking at this angle, what do we have relative to it? Well, we have the opposite and the adjacent known. Anytime you have the opposite and adjacent known for your angle, you can use tangent to solve very quickly. So let's write this out. So the tangent of my angle theta is equal to the opposite over the adjacent. So let's fill this in. So tangent of theta is equal to 4 square roots of 2 over 2. So 4 square roots of 2 divided by 2 gives me approximately 2.83. So then my angle theta will just be the tangent inverse of that value of 2.83. So theta will pop out to be 70.5 degrees. So there's my angle for the second one, which is 70.5 degrees right here. Now, a few notes here, just before we do our last one. A couple of things when you're doing your calculator, make sure that your mode of your calculator is in degrees, because sometimes calculators will come preset as a radian function. And we've gone over videos, or we have videos on the channel that are going over how to translate between radians and degrees. So please check those out if you have that issue. But please make sure that your calculators, if you're following along here, or you're working these types of problems, make sure they are in degrees rather than radians, if the problem is asking for specifically degrees. The other thing, please make sure that when you're using this negative portion right here above the sine inverse and the tangent inverse, that is not saying that it is sine to the power of -1. It is not the same as saying x to the -1 power. Whenever you see your trig functions with the -1 here, that means that's the inverse function of that value. So it is not this right here. It is a totally separate instance, which most calculators, if they have sine, tangent, and cosine abilities, you will also have the sine inverse, tangent inverse, and cosine inverse abilities. So just a few points of notes there before we continue on with our last one. So last triangle here on the right. So we have the angle here on the left side. Well, the adjacent side is the one touching it. The opposite is the other side that is not touching the angle that connects in to our right angle. And then our hypotenuse is our longest side that is opposite the right angle. So what do we have here? Well, we have the adjacent and we have the hypotenuse. Well, that would be cosine then. So cosine of theta is equal to my adjacent divided by my hypotenuse. So the cosine of my angle is equal to 6.5 divided by 55. Well, 6.5 divided by 55 gives me approximately 0.118. So my angle would be the cosine inverse of that value of 0.118. And my angle from this pops out to be 83.2 degrees. So that means that this angle here, given these sides, must be 83.2 degrees if a right triangle is to be formed. So that's how you would use sine, cosine, and tangent very quickly to solve for angles inside of right triangles given certain dimensions. Now, you can always find the other side of the triangle using Pythagorean theorem if you want to, but this just shows you how to utilize two of the sides to find the angle rather quickly. So I hope this video was helpful. And if you want to see more problem solved this Friday, please check out the other videos on our channel. Also, if you haven't done so already, please like this video, leave a positive comment below, and subscribe to the channel because all of that does help us over here. Thank you for watching, and I hope you have a fantastic day.